Today we're going to talk about distance and displacement. The topics we'll talk about are distance, displacement, distance and displacement with vectors, and then we'll do some application questions to look at the big picture. This is Fred. Fred just got a new car. He drives it to school, which is 1,000 meters from his house. After he gets there, he realizes that he forgot an apple for his physics teacher. He drives to the store, 400 meters away, gets an apple, and then drives back to school. How far did he go? At this point, pause the video and answer the question. And I want to point out there's more than one correct answer for this question. So the reason there's more than one answer is that this question isn't really worded very clearly. It just says how far, but it doesn't say how we're going to measure how far he goes. The first way we can measure it is using distance. Distance is the total length of the path that Fred took. So this includes his drive to school, 1,000 meters, his drive to the store, 400 meters, and his return to school, 400 meters. If we add each of those distances together, we get a total distance traveled of 1,800 meters. Now I want to point out that distance is a scalar. We're going to talk about scalars and vectors this year. A scalar is something that has a magnitude, and a magnitude means a numerical value. It'll include units in physics class, so a number and units, but it doesn't have a direction. So it's not 1,800 meters north, it's not 1,800 meters south, it's not negative 1,800 meters, it's just a distance of 1,800 meters. Now the path that you take matters for distance, so it matters that he went to the school, to the store, and back to the school to get his distance correct. You need to know the path. The second way we could answer the question, how far does he go, is just by looking at how far he goes from his starting position to his ending position. How much did his position change from the beginning to the end? This is the displacement, or the change in position. Now, to do this, we're going to use some variables and an equation for displacement. And this is the equation for displacement. And it says that delta x, which is the displacement, is equal to the final position, this is the final position, minus the initial position. So delta is a Greek letter that means change. So this is saying what is his change in position? And once I find his change in position, it'll be the displacement. This letter, xf, is x with a subscript, that's a smaller, lower letter of f. F stands for final. So this is final x, or final position in the x direction, minus x initial. And this I stands for initial, it's a subscript also. So final position minus initial position will give me the change. So we always do our final first minus our initial when we do any equation that uses delta in it. So for Fred, we're going to identify his starting position, and we'll say he started at x position of 0. So that means our x initial is 0 meters. Now it doesn't matter where he went. What we care about is his final position, which is at the school. And the school is 1,000 meters away from his house. So his final position is going to be 1,000 meters. Then we can find his displacement, which is his final position minus his initial position, or 1,000 meters minus 0 meters. And it gives us 1,000 meters as his displacement. You'll notice that's different than his distance, which was 1,800 meters. So displacement is a vector. That means it has a magnitude or numerical value, 1,000 meters, and it also has a direction. In Fred's case, the direction is the positive x direction. Now, we could have written it as plus 1,000 meters. If he had gone backwards to the left, it would have been a negative displacement. So it does include direction when we look at displacement. Now, the path that you take doesn't matter when you talk about displacement. So it doesn't matter that Fred went to the store and then back to the school. All that matters is where did he start and where did he end. So those are the two different ways that we can measure how far something goes. So let me just summarize displacement. It shows that from the beginning to the end, ignoring the path he took, Fred has increased his position in the x direction by 1,000 meters. So generally, when you get a question in physics, it'll ask you what is the distance or what is the displacement, not how far, because how far is too general. So let's do a practice problem. Now this time we're going to look at it using vectors. Now there's not, right. So we'll start with Francine. Here's Francine right here. She's going to go 22.0 meters east, then she's going to go 32.0 meters west. And the first question is, what distance did she travel? So remember that direction doesn't matter for the distance calculations. And down here I have the equation for displacement, but we're not using that yet. We're just looking at distance. So pause the video and answer the question. All right, her distance includes 22 meters, that's the first part of the distance, plus 32 meters. Her total distance is 54.0 meters. We just add those two distances together. All right, next, what is her displacement? So we want to know from her starting position to her ending position, what is her change in position? Now this one's a little bit trickier because we have to figure out what this position is over here, and it's not told to us. We're only told how she travels along the way. So it's going to be helpful to draw an x-axis, and I would define her starting position as x equals 0. Figure out what is her initial position, xi, figure out what is her final position, and then use that to solve with the equation. Now east is going to be positive and west is going to be negative. All right, pause the video and answer this question. Okay, so we're going to set up our coordinate system with her position starting at 0. X initial is 0 meters. She goes to the east, then she goes to the west, and she ends up at her final position. Now to figure out her final position, we're going to add the vectors. So 22 meters is a positive vector, and it's going to be 22 meters positive minus 32 meters because the west direction is a negative vector. So her final position is 22 minus 32, which gives us a final position of negative 10 meters. And that makes sense because we know that she starts at 0 and she ends up on the left-hand side, so it should be negative. So we identify x initial is 0, x final is negative 10, and then we plug it into the equation, x final minus x initial. So her final position is negative 10 minus 0. It gives us a displacement of negative 10 meters. Or we could also write it as 10 meters to the west. All right, let's do a problem to apply these ideas. So this is from last year's physics class. We launched a pumpkin from a trebuchet, and I'll show you the video what it looks like. And I want you to think about, how does the pumpkin's distance compare to its displacement? Is it smaller, larger, or equal? And then use a picture to support your answer. So let's watch the video of the launch. So the pumpkin starts down here, and then it travels to that point. So think about, how does the pumpkin's distance compare to its displacement? Is it smaller, larger, or equal? And then draw a picture to support your answer. So pause the video to answer this question. All right, so here's a picture. We have our pumpkin. This is approximate. Starts here, and the distance it travels, it goes up and around and back down. Gravity pulls it back to the ground. That's its distance in red. Now its displacement is change in position. That's going to be the amount that it travels from beginning to end. It's on the ground both at the beginning and the end, so we only need to worry about the x direction. So from this picture, we can answer that the distance is going to be greater. So the length of the distance you can see in the picture is greater than the length of the displacement. To summarize, The distance is the total length of travel. The path you take matters. It's a scalar. It has magnitude or numerical value. Displacement is how far it is from your starting point to your ending point. The path taken doesn't matter. It's a vector. It has magnitude, numerical value, and direction. And here's your equation for displacement that you can write down as a reference. Thank you.